questions we have already discussed. This is the third one. देखते हैं इसमें क्या है. ये तो बस कहानी, ये डिटर्मिनेंट मॉड एम तो डिटर्मिनेंट एम का डिटर्मिनेंट ही होता है, इसमें बताने वाली क्या बात है. ई एफ एंड पी 3 मैट्रिसेस गिवन है और आपको बताने हैं कि ए बी सी डी में से कितने सही है, क्या है, तो सब देखते हैं. तो फर्स्ट ऑप्शन में ये पी स्क्वायर है और एफ इज इक्वल टू पी ई पी है. सो फर्स्ट ऑफ ऑल कैन वी फाइंड पी स्क्वायर, दैट सीम्स टू बी इजी. So let's find that. P square means what? 101, 001, and 010. If this gets multiplied by the same thing, what will happen? 010. Just multiply them. Here 1011. This is just one. This 0000. Just multiply it. 0 0 no 001 000, and 0000. This is this. You got what? You got an identity matrix I. So P square is this. You got this. Simple. So this is true. In first option, this part is true. We have to find this PEP, whether PEP is equal to F or not. So we have P here, simple matrix, and we have to multiply it, pre-multiply it by E. So we will have to do it like this. This is our P. P means 0, 1, 0, 0. इसको we have to multiply with E. 1, 2, 3, 2, 3, 4, 8, 13 and 18. इसको मल्टीप्लाई करके देखते हैं. ये हमारा क्या है? ये है P और ये है E. We are multiplying this two. Let's see what happens. So ये again post multiply it by P. So इसको फिर से हमें E से मल्टीप्लाई करना होगा. E से नहीं, P से again. So this is 1, 0, 0, 0, 0, 1 and 0, 1, 0. Just multiply and get 2, 4, 3. Now check it, which matrix this is. So we multiply what? We did P, E, and then P. We multiplied this as said in the question. And this is equal to this matrix. And this matrix is nothing but F. So this is true. Option A is true. It was quite simple that you have to just multiply P, E, P and get the answer. So it's simple multiplication till now. Nothing more to think. Okay. Come to the next one. How we will go for B? This is determinant of this complex matrix is equal to determinant of EQ, and this is PF. What is Q? Q is a non-singular matrix of order 3 cross 3. So Q is any other matrix other than E, P, and M. Right? Q is any non-singular matrix. We can take A, B, C, D, E, F like that. Okay. Yeah. Okay. So for a try, let's see that what is the determinant value of EQ, but we don't know what is Q. So can we find determinant E? Yeah. So try to find determinant E once. So let's find out determinant of E. Okay. So this is 1. Or can we do any operation here to get it easily? If you do this, C1 is C1 minus C2 and C2 minus C3 equal to 0. So determinant E is equal to 0. So what will be determinant of EQ? We know it very well that determinant of EQ is nothing but determinant of E into determinant of Q. So the entire value is 0. Okay, so this value is 0. Okay. Now let's see the value of this PFQ inverse. We know what is F. Yeah, F is PEP. So let's figure it out. What is it? PFQ inverse. P is P and F is PEP, and then Q inverse. We have to find determinant of this. And you know that if all the matrices are written like this, all are multiplied, and their determinant is equal to product of determinants of individual matrices, right? So here, if you find the determinant value of this whole thing, this will be, just 1 second. Yeah, this will be determinant of the entire thing, P, then determinant of P square, or we can write it like this also, P square determinant, then determinant of E, and then determinant of PQ inverse. The thing is, the determinant E is 0, determinant of E is 0. So this whole determinant is equal to 0. It means this is also 0. So on the right hand side, we have something, we have 0, simple. So if on the left hand side also, if we get 0, then option B is also correct, right? So let's find out the left hand part. Left hand part, this is EQ, okay. PFQ inverse. PFQ inverse is basically what? This is PEP, so we have E here. So if we try to write the left hand part, EQ plus PFQ inverse, right? Try to write the matrix first, and then we will apply determinant. F is PEP. This is EQ plus P square. P square is I. P square is I. So just don't write that. This is E P Q inverse, right? We can take E common, and then this will be Q plus PQ inverse. And now we have to take determinant of weight, which is equal to determinant of E into the determinant of Q plus PQ inverse. And determinant of E is 0. So this whole determinant is equal to 0. So what we got here, on the left hand side, the entire determinant is equal to 0. On the right hand side, it is already 0. So this B option is also correct. So till now we have two options, A and B. We'll check for C. Okay, check for C. Okay, so very clearly we know that this EF cube determinant is equal to this, and this is equal to determinant of E cube, determinant of F cube, and determinant E is 0. So EF cube is on the left hand side, we have 0. Okay, what is on the right hand side? This is also 0. So here both sides are equal, but in the question it said that LHS is more than RHS. So this is not the right answer. Okay. Any doubt? Here, just find the determinant, you'll get exactly 0 because E determinant E is 0. On the right also we have E. So on the right also we have 0. So both are equal and not unequal. So come to the D option. Sum of diagonal entries of P inverse EP plus F. So let's try to find out what is P inverse EP plus F. Right, we have F is equal to PEP. And here we have P inverse EP. Student, one more thing I'll tell you. P square is equal to I, right? It means P into P is equal to I. It means we have multiplied a matrix P with P. We have multiplied a matrix with P, which is making it I, right? So remember that if AB is equal to I, then B is inverse of A. So here P is inverse of P. So P is equal to P inverse. So this can be written as PEP because P inverse is equal to P, right? PEP plus F. So PEP is F from this option, from the finding F plus F. So this is equal to 2f, right? So P inverse EP plus F is actually equal to 2f. Okay. So we found what it is. It is actually equal to 2f. Okay. If we try to find out this, let's do that. So this is actually E plus P inverse FP. Write that here. E plus P inverse EP. And P inverse is equal to P. So we can write E plus, and what was the finding? F E is equal to, one second. F is equal to PEP. F is equal to PEP. So uh, F is equal to PEP. Here P inverse EP. So PEP, we can write PEP. Okay, and that is equal to F. But here it is PFP, students. It is not P inverse EP. This is P inverse FP. We have to find this. Okay. So this is P inverse. And we know that P inverse is equal to P. So we can write P inverse as P. And what we can write for F? F can be written as PEP. F is equal to PEP. So write that. F is equal to PEP. P inverse is P. F is PEP. And then again P. So P square is going to be I. And then E. And then again P square. So this is I. So this is actually equal to E plus E, which is 2E. So this was 2F and this is 2E. So let's go for the options once again. And this is 2F and this is 2E actually. Now we have to get the sum of diagonal entries of F. This is 1 plus 18 plus 3, 22. Okay, so 2F will be 44. And E, 1 plus same. So diagonal entries are same in case of F and E. So sum of diagonal entries of both will also be same. So option D will be the correct answer. So finally, we have A, B, and D, our right answer. If you see it from the beginning, what do you find it? Is it a difficult question? To get the first option, it's very easy, I think. You have to just multiply PEP, simple multiplication, get F, P square, you're getting I, done. Then you are just looking at the second option, E is everywhere. E is everywhere. So why not to find determinant of E? Once you find determinant of E, which is 0, and then you found that on the left hand side and right hand side both are 0. That's it. So on the basis of determinant, on the finding of that, you can find option C also, right? After that, it's option D. This is actually equal to 2F and this is actually equal to 2E, right? How you got it 2F and 2D? From the finding or from the option written, from this. Okay, and after that, you just calculated the diagonal entries sum, and because both have same diagonal entries, their sum would also be same. So it's not very difficult, moderate. Okay, so we'll move to the next question.